Okay, looks like numbers are settling down. So hi everybody again, and welcome to, actually it's November, so 11th editions of ARK Roundtable. So we're very happy to have you guys here, and happy Thanksgiving to all the guys who are celebrating, especially the US sides and around there. So hope you're having a nice time with families, and if you took time to join this roundtable, so we are happy to have you. And well, in today's roundtable is maybe a bit different, so we'll be not looking into AIPs into more details, but we have two building blocks. Basically, one building block will be around ongoing activities in the past month related to ARK, the testing, the release 2.6, and a short introduction to blockchain oracles. And then in the second part, we have a special guest, Dean, who is the founder and CEO from the nOS platform, and they built something really awesome, which is a Oracle module that runs on ARK network. So we are very happy to have you here, Dean. So we're looking forward to your presentation.
Glad to be here. Thank you. Yeah. So am I gonna take it away from here?
Just give me a few more minutes to just jump through the recent activities and to make a summary of the previous months, and then I'll give you the slides. So let's say if you're looking at the previous ongoing activities in the last month, development related, everything has been circling around the blockchain framework and our 2.6 release, which is actually a very important milestone because we are introducing something that we wanted to do since 2.0 release, which is the AIP 11, new transaction types, better security. We are introducing a concept of building distributed applications on top of ARK by using our blockchain framework, which you can split it in different modules, like building it with plugins, and inside different modules you can actually pack any kind of custom transaction types, and these types have similar functionality than let's say the smart contract. So the blockchain 2.6 framework is out for testing. You can see it on our develop branch. Just head over to that link. And we are also running a public donate bounty program. So if you click on the leaderboard.ark.io, you can see that we have quite a few contributors, Dated being among the most active ones. So, and the top 3 bounty hunters get also a special bonus. So we actually invite you all to take part of the public donate testing and also earn some money along the way. Besides this, we are also running ongoing active development bounty program, which is always active. You can head over to bounty.ark.io. We have different tier programs from tier 0 to tier 5. Basically, these bounty programs are related to specific applications or products that we are having. And a special section of this bounty program is also a security bounty program, which is especially targeted for our core platform. And this one is has a bit higher ratings because it's actually related to the blockchain protocol. So if you can fake some data, make ARK out of thin air, so or affect the consensus mechanism, put state in a, let's say, unrecoverable state, or may cause a fork on the network. So if you think you can contribute on this would be actually a very nice place where you could start to learn about blockchain, to learn about framework, to learn about different consensus mechanism, and then try to hack your way in. So if this is something for you, check out our security program. And we have, oops, that was a quick jump. Okay, we have also a few job positionings open. So we are looking for senior blockchain developers, full stack developers, growth marketeer. If you want to join a flexible team, a remote team, we are all, let's say, mid 30s, 40s, 20s. We all love blockchain technology, and you're available to work remote. If you want to work with TypeScript, Node technology, Postgres, feel free to send us to check our website, send us your CV, and we'll take it from there. Okay, so that's something that I wanted to mention on the start before we go into details. But today's topics, as we said before, will be around oracles, and well, not that kind of oracles. So we're not referring to somebody that's going to tell us the future if the market is going to be a bull market or a bear market, and also not these kind of oracles, but we're talking about tools that allow blockchains to learn the outcome of an event. So basically, oracle naming is maybe a bit strange because it connects us to something that happened in the future, but it's actually related to something that happened in the past. So that's why we use oracle. So we don't make predictions about the future, but oracles are actually the tools that enable us to use the existing information that happened in the past and decide and build a report. They report to us, and then our application or any logic that we build around it builds upon it. Why do we need them? But well, if you think of the blockchain development in general, so all applications that are running on a public blockchain, they require some kind of triggers in order to provide a service. And this trigger is some kind of action that is based to some kind of event that happened in the physical world. Yeah, these triggers could be coming from specific users, like initiating transaction, some special event in the real world, which can be any kind of event, like some kind of a confirmation or some kind of event related to, let's say, supply chain management or some package going through different stages. So all these are information that are based on the physical world, and let's say blockchain mechanics, smart contracts, or distributed applications rely on gathering data from them and then building states on top of it. And if you look more deeply, we, as you can see on the pictures below, there are like two mostly types of oracles, and these are machines and users. And AI is actually maybe the third type, but that is more like an application of it. But in essence, sensors are used as oracles in automation, IoT, where they generate sensor data, supply chain data, like tracking some kind of items, tool boot payments, automatic payments. So all this can be stored on chain, or we can just query a trusted oracle and include it in our custom logic. I don't want to go any more into details on Oracle, so we'll see how Dean actually built the Oracle plugin, which is based on our blockchain. So we are joining the platforms that are already out there providing Oracle functionality, but we also want to show how flexible our core is by just using modules and dynamic connectivity with the blockchain protocol. So with reading the blocks, building custom transaction, making changes to, let's say, to the consensus protocol, how we can connect this in a special plugin and just build an oracle on top of it. So I'm really looking forward to Dean. So Dean, take it forward. So I would love to see how you build the plugin and to discuss, let's say, your technical decisions on top of it.
Yeah, happy to. Can everyone hear me okay?
Yeah, perfect.
All right, cool. Always the first question you got to ask when starting a meeting, right? Can you hear me okay? Is my screen working? Sorry, I need to reconnect. Yeah, let me get my screen going. It's the second part. Yeah, I guess we can go with this monitor. Yeah.
I'll make you a present. Oh, you have it already. Okay, perfect.
All right, you can see this, right?
Yeah. Do you guys see it?
Yeah, I see that fine.
All right, sweet.
Yeah, we do.
So you already gave a good explanation about how oracles are. Oh, I need to. Damn it. Let me. Now I need to get rid of my screen again.
Okay.
Give me a second.
Yeah, no worries.
Okay, it's gone now.
There
you go. Okay. And we are. This is my first time using GoToMeet, so I need to get a little bit familiar with it.
Sure, no problem.
There we go. Okay, so I'm Dean van Dugteren. I am the founder of nOS. I am also the guy who's building the blockchain, essentially. So nOS is, well, the blockchain based on the ARK framework, which has helped us a lot because it makes my life so much easier to build things, especially when
nice to hear that.
Yeah, no, it's true. And so first, a quick explanation about nOS. nOS is a platform that allows developers to easily integrate apps with cryptocurrencies, and it makes it easy for users to discover crypto apps. And it also makes it easier for apps to be monetized with different blockchain monetization models. nOS has an app store, which is decentralized, and it is powered by a DPoS blockchain, delegated proof of stake blockchain, which is built with ARK core technology. So on nOS, delegates don't only have the ability to mine blocks, they also manage the app store by curating apps. So that's called the curator system. The network itself, nOS itself, does not give extra block rewards for curating apps. It's something that delegates can do to expand their own business models and earn more votes and earn revenue. And it's up to each delegate themselves to make their curator service into something profitable. But so we employ a delegated proof of stake in a technical perspective, where the nOS holders of the nOS coin. I call the coin nOS in the project nOS, by the way, just so you know. The delegates don't only forge blocks; they also have a managerial approach where they actively can do something which is viewed by end users, right? Which is the App Store. They have the management position of the App Store. So, how are we building that? So right now, the features that are unique to nOS are built as a series of plugins, custom transactions with the generic transaction interface, or GTI, and some modifications to ARK's native core code base. But we don't expect that we'll need to make those core modifications when ARK 3.0 is released. Right now, we need to do a small amount of modifications in our fork of ARK, but we expect that we can do everything with modules in version 3.0, but 2.6 is already very much ready for us to build our mainnet. So we're building our mainnet and all our features now, and then we're just gonna modularize it and make it easier, more upgradable, and easier for other blockchains to also utilize the transactions and the systems that we built for their own blockchain as well. nOS essentially, a lot of it is an app store, is a big part of nOS, and having more blockchain developers building crypto apps, building blockchain apps is of course great for nOS, because these are apps that would actively benefit from getting exposure on a decentralized application store, right? A decentralized app store. I like to say app store that is decentralized, because otherwise it sounds like the app store, but it's not exclusive to the apps. It can be any kind of app, it can be crypto apps. It could just be a link to somewhere, but yeah. So firstly, as I said, I love building with ARK. I also enjoy working with the ARK team and trying to make core contributions as well, improve the framework, and I highly recommend it to anyone who's looking into building a blockchain. You don't need to know anything about smart contracts. You just need to basically understand what makes a blockchain, and you need to know some of the basics of TypeScript. I mean, the better you are at TypeScript, the better you will be at working in a TypeScript framework, which is what the ARK core is. But yeah, so if you're a web developer, I'm sure you might be familiar with JavaScript or Node.js. Then TypeScript is a breeze to pick up, and then you can also pick up ARK core blockchain development. So for this guide, I'm going to assume that you understand these kind of basic principles. And if not, then you can check out the ARK developer documentation after this. I believe it's ark.dev or docs.ark.dev. Is that right, Kristjan?
Yeah, I think it's docs.ark.io, and then it links you to specific pages. Either it's SDKs or APIs, or just starter tutorials, which are basically on learn.ark.dev. We'll drop some links.
Okay. So
I'm just curious. You know, you were saying that you liked how is your experience with ARK blockchain? How fast? How much time did it take you to make the switch? You know, like you are like a front end web developer, and now you're like hacking the core mechanics of blockchain. So learning wise or effort wise,
right.
how
So me
long did it
personally,
take you to make your first plugin or something like that?
I've been a full stack developer for a few for an amount of
Okay.
years, right? I already built Click DJ, which is a big music marketing application, but that the backend for that is in PHP. I did know Node.js as a necessity for modules, small backend services that I needed, some
Okay.
semi real-time stuff. So I did indeed know some TypeScript, JavaScript, and Node.js. I never really dove deep into TypeScript, so working in with ARK was pretty much my first serious TypeScript introduction. And
Okay.
I would say, well, so it was. I'm not sure when I started with ARK. It might have been December or January when I first really started programming with it, right? But back then it was it took more time to pick up because ARK obviously was just at version 2.0, I think, or maybe 2.1, which was not really modular yet, which it is now.
Yeah.
So it was harder to do some things, and you had to really dive deep into the code and how things are, how blocks are signed, how transactions are signed, and all of that is no longer really necessary. A lot of it is taken care of right now. So I would estimate if I were to start now with version 2.6 as a full stack developer or as a developer who knows JavaScript, you should be able to build a blockchain after maybe if you already know the principles of blockchain, maybe one week of a few hours every day, and you should be able to comfortably build custom transactions.
Perfect.
Yeah, that's my estimation. Could be longer, could be shorter. It depends for everyone, but I think that the documentation, everything that's available now, it should be quite easy. And of course, if you're a less experienced developer, but you are experienced in but you know how to set up things like a WordPress blog. Obviously, with the ARK deployer and the plugin system, you can drag and drop essentially a plugin included in a file and launch your blockchain. It can be that simple. But if you want to really build something that is really custom, really proprietary, then you do need to learn as you would learn any other framework. But I feel like ARK is one of the more accessible and easier to understand frameworks. In the same way that, I don't know, like Yi is for PHP or Laravel, yeah. So
yeah, I mean, we're really happy to take away the complexity, that if you want to build something on top of blockchain, like you said, custom transactions in a week or even sooner, you don't have to know all the other mechanics of the blockchain protocol, but you can just use it as a template and just build your logic around your plugins and modules, or essentially custom transactions if you need them. So to me, after 2.6 or after 2.3 already, it's like a that flashback from the web application era where you just spin up one server and that server is running somewhere in the background, and then you're just pushing different applications inside that server. So essentially our core framework is giving you exactly the same. So you just start the framework, and then you deploy your applications on top of it. And these applications are of course much easier maintainable, let's say, than smart contracts, because you have the source. You can change the source and connect it to, let's say, different blockchain milestones. So it's much easier updatable than a smart contract would be. So
absolutely.
and it's still TypeScript.
Yeah. You can essentially approach it like a framework. Or you can and that's what what experienced developers do to build like a really custom thing. But you could also approach it like something like WordPress, right? Like an all-in-one kind of setup where you just install your plugins, and launch your blockchain. You can basically take both approaches and just kind of scale and adapt as you improve in experience. The most important part is you don't really feel like you're studying, like you're really studying. you're just doing things. You're
Yeah.
trying things out with transactions. You're experimenting, and by doing that, you're learning. And the most important thing to take away is that building with ARK is fun, and that's what it has been for me, especially, is that I find working in ARK to be a joy. I think it's really fun to just to try things and to see it working in action, and to be like, oh, I actually built something which I envisioned, and now it's working, and I can see that you can make a transaction and you can use it in wallets. It's just really cool. It's really fun.
Yeah.
It brings the fun back in development.
It's very important, actually. That's why we also love this job so much.
Yeah, understandable. So so you did a good job explaining the Oracle, how oracles work. It's useful for apps to sort of guarantee their users that an app themselves are not the provider of key information, but instead a decentralized network is. With oracles, every user of an app can verify the requests it makes, what data it receives, and how it processes it. All of that can be open source. So a good example is decentralized or semi-decentralized sports betting, where a betting app wants to give the user some assurance that the winning sports team is not decided by the app, but instead by, for example, 51 nodes that verify the results, the winning team. And then all the users can verify how is the data requested, how is it processed, how is it being reviewed by this app. Another good example is a finance app, with DeFi and stuff. They use oracles a lot, or sometimes, where they want to provide their users with a transparent way to retrieve, for example, the price of Ethereum. Right. So I decided on this concept for a guide because I believe it is a relatively simple concept to grasp, and it helps you get an understanding of how transactions and plugins work in ARK. I actually have this boring white page open. It might have been cooler if I put up like some code or while I was talking, I don't know if you guys can see this, but here we have a blockchain going on.
Oh, yeah.
That would have been pretty cool, some animation. But yeah, now you just have me. So how did I achieve this with ARK Core? How did I so how do I want to achieve this with ARK Core? So the features that we need to make something like this happen is the ability for an account to post a URL of an API endpoint to the blockchain, right? For example, a URL to receive the price of Ethereum. One decent example of that is CoinGecko. They have a nice API, and here you can see the current Bitcoin value of Ethereum in a JSON object. So that's one thing that we need. We need we have a link, this is the URL to the API endpoint. We need to get that on the blockchain somehow. We need to have an app, give apps the ability to post those URLs to the blockchain. Then the delegates on the network, these are the forging nodes, right? With ARK, for example, you have 51 forging nodes. With your own blockchain, you can set as to many or as little as you want. These delegates, they should see this URL show up on the blockchain. They should make the request to it automatically, receive the data in it, which is the price in this case. And then they need to post that back to the blockchain so that the app can utilize that data, right? You following me so far?
So all the delegates receive the price, the price request, and all the delegates have to confirm it to be valid.
Essentially, yes. So the delegates, what they do is they send the data back to the blockchain in this specific case, right? In this specific way that I built the blockchain as a basic example for how oracles are done. All the delegates send back the raw data that they receive, and then it's up to the app to process it. Right? They can decide if that data is valid or not by checking what the majority of the data is, etc. So it's up to the app to process it. It's just that if you would request it currently in this current example, so currently there's one delegate node because it's a test net for development. But if you have a full network with 51 nodes, you would get 51 results back, and you would and your app would process it however they want. So here's an example. So this is connected to this app here, this little app here is connected to this blockchain, which is running in a virtual machine. And this front end is connected directly to the blockchain. I can show you the network here. You can see like a small login screen flash by. It automatically logs me in as a user with funds on the wallet, testnet funds. You can see here it makes a request. I don't know if you guys can see this, if it's big enough, but it's making a request to an API endpoint of a relay node, which is on my local host, to a wallet. This is just to get the wallet information.
Yeah. Okay.
And this is a request to a delegate, which is I'm not sure why it's requesting the oh yeah, because the wallet is a delegate, I guess. Anyway, so if I enter a URL here and I click on request Oracle, this is Oracle request. It just made a transaction to the blockchain, and now it is you can see the transaction request being made here, and now it is querying the blockchain, and there it is. You can see this data object of the Ethereum price being returned. This is data that is now on the blockchain. It's been returned by my delegate, by my node. So all of this is verifiable. Let me, what's the port to the block explorer? Oh, we don't have one right now, but yeah, so it is on the blockchain. I can show you
it's the same as API. Yeah, you can see the transaction here.
Yeah, you can see the transaction here. So you can see here that a new Oracle was requested for this URL here. It queried the URL, the nodes. This is the node application, right? So it looked up this URL. It got status code 200. That means it was accepted. It got a response, which is this body here. And it generated a transaction. This is a transaction for ARK, which is being generated, signed, and then it's broadcasted to the blockchain. Transaction success.
Who generated the transaction? The forger, the delegate. Who signed these transactions? Basically,
the forging node. Yeah, it's a plugin which runs on the forging on a node. So the forging node, it signs the transaction and posts it, but it could be a separate plugin. But this is running with it could be a separate application because it utilizes the private key of the node. That's all it really needs. But it's also listening to incoming transactions. So you might as well. So you'd have to run this on either a relay node or on a forging node. On a testnet, it runs both in one application, right?
So as a client user, somebody who's developing, let's say, a mobile app, or somebody that wants to just get a secure or trust verifiable Ethereum price, I make a request on your blockchain. In this case, this is simulated on your local node. I share the request URL, and then this URL gets picked up. And it goes for all the delegates
and posts it back in another transaction.
So each of the secure forgers, so each of the delegates then checks and verifies this URL and stores it as a transaction.
Yeah, all of them. Yeah.
So basically 51 delegates, that means that we get 51 confirmed
if you have
views
51
of the state outside,
Yes, if you have 51 delegates, you would. So the way this little app here is made is, if you have multiple nodes, you would just see 51 results all below each other here. Now now you have one because there's one delegate, but if you have a real live network, this would show different results. So this app, obviously, this is just to test it out, but usually, as you said, it would all happen in a backend. So a mobile app would make a request for a prize, for example, or a winning team or whatever they need in the backend. The user doesn't even have to know about the blockchain, but they could find out if they want to, and then they can verify how the transaction is done, right? How the data is verified. So it is the basic premise of an Oracle, and I'm going to show you how I did that, how I made that, and it's cool because it integrates basically a little bit of every cool thing that you can do with ARK. You build a plugin for delegates to listen to incoming requests and then make a transaction with the data that's coming in. You need two types of transactions. One to let anyone make Oracle requests by providing an API endpoint, right? And one transaction that allows the delegates to post a result. And third, we need a custom API and database that allows these third-party apps to easily request all this Oracle data, right? Because you don't want apps to create their own complicated systems to receive all the different transactions and maintain their own database. So we're going to have a custom database within the nodes, which is separate from the blockchain database, that maintains this information about the different transactions. So I'm going to show you what that looks like, because I actually built this plugin initially for nOS. We're using it for nOS for staking information, tracking staking information. So we needed sort of a database that allows us to easily query all the stakes that were created after or before a certain date. Right. So with the Oracle system, it's a bit easier. So this is the structure here on the left. This is a structure of the file structure of an ARK blockchain, an ARK core blockchain. And one of the most important, two of the most important folders are packages and plugins. That's where you'll spend the most time in, and mostly plugins, hopefully. So in our case, we have the Oracle system is entirely plugin based. There are no core modifications. So we have, I'll go over this real quick. We have a server plugin, and what this is the part that listens for transactions. I'll show it real quick.
It enables you to hook your own API, yeah, any kind of API. Yeah,
as well. So in this case, this is directly connected to the relay node. It listens for a custom event called Oracle requested, right? And then it looks up what data, what URL is being requested, and then it builds a transaction and it returns it. I'm going to go over this a little bit more in detail in a bit. I'm just giving a short overview. So that's the event listener. Then we have transactions. So these are the transaction handlers. So this is the backend, the business logic for transactions. So making a request is really simple right now, and you could essentially do this with like vendor fields or something. But I wanted to make this a custom transaction because I want to show you how it's done, and it's also intended to give you sort of a starting point. So if you want to make it more complex, if you want to integrate more logic into this, you already have your custom transaction set up. So in this case, this is the business logic for a transaction, and basically everything we have here is just emitting the events that an Oracle is requested. And the transaction is already posted by the apply to sender super function. There's actually not a lot happening there because there's no funds used except for paying for the transaction fees. All of that is taken care of by ARK. So if there's a transaction fee, ARK already handles, dealing with funds and fees and transaction anti-spam, all that kind of stuff, consensus. That's all taken care of. Then a more interesting one is the Oracle result. There's a bit more in here. So we utilize the throw if cannot be applied, which is validation. It checks if the wallet is an active delegate. This is for results, right, of the Oracle. So we want only active delegates to make this transaction. So we check the active delegates, and then if the current wallet is not a delegate, am I saying that right? Yeah, so if the signing wallet, if the sender is not a
delegate list
found in the active delegates list, then it returns an error. So the transaction won't be posted. That's all you need to validate stuff, right? Also, if the transaction ID for the request isn't found, then it's not a correct result. So then we need to check for correct transactions as well. We're checking if it can enter the transaction pool. I'm going to go over this a little bit more in detail as well. But yeah, so all the business validation for checking things before they really get allowed into the blockchain is done with the handlers. So that's the most important part of the core of the transactions plugin. Then we have another transactions plugin, which is the crypto part, and this part is for signing transactions. Another way to look at it is the crypto part is where you build up the model for your transactions. So the schema, this is the data that a transaction should receive. This is how it should be signed. Maybe you don't have to do that you don't have to do a lot with that, but you're just basically setting up the schema. Let me see if I can get that here. So for making a request, you build up your schema here. So you're saying the request requires some data, which is a URL. And that's what we're saying here. We're expecting a URL to receive a URL as a transaction in this transaction, and then we sign it. But this happens on the client side. So we don't need all that backend logic in the same plugin. So we're separating these two. So a front end or another app only needs to import this crypto part for signing the transaction, and then they can just broadcast that to the blockchain. They don't need the handlers and stuff, because that's stuff that only delegates need and only forging nodes need. So,
but they get the full crypto logic. So all they have to do is import the plugin you published on npm, and the payload of the transaction is generated. It's signed. Additional data is done. So the whole concept of serialization is taken care of. So all a client has to do is just import a module, call a function, and throw in the URL you were talking about. So get my Ethereum price, and it is signed, packed together, and sent to the node from the package.
Yeah, I can show you how it's, this is the front end application. You can see I'm importing the builder and the interface here. You only need to import those together with the with ARK's crypto module. And then you build a transaction just like this. This is how easy eventually it gets to build a transaction. So making an Oracle request, all this logic, it's basically a function that works like this. And I can leave this out as well at this point. All you need to do is, so here's Oracle request, which is an object, which just contains the URL. Here you can see it being built. It just says Oracle request is an object with the URL. We provide that. Oracle request asset is URL, sign it with the mnemonic, and then you get struct and broadcast it with whatever HTTP posting module you want, function you want. So all of that logic, which you saw here in the builder, here for making a request, this is actually quite simple, and it looks a little bit confusing at first, but it's all quite simple to understand once you understand how it's structured. Things like amounts, how much funds should be attached to this transaction. It's not a transfer, so we don't allow any number of coins to be transactions. So it just says minimum 1, minimum 0, maximum 0. So there's no coins that need to be attached to this transaction other than the fees. We're expecting an Oracle request, which is an object. Then we give it the property. So Oracle request is an object that is that requires a URL as a value. And all of that converts to eventually doing this for making a transaction. So that's for the transactions part, quick overview. And then we have the storage plugin. So the storage plugin is a separate database. It runs on type ORM and SQLite. So, or SQLite, I'm not quite sure how to call it, but what it basically is, it's very simple. So building a plugin on ARK is basically like building a module in any other application. So I added type ORM as a dependency. I imported in a new plugin. I import create connection and get connection, and then I just set it up in the register method. So I create the connection, I set up my details, start the server, that's it. You now have a running database which you can access from anywhere in your nodes, your plugins. There's another. So this is where when a transaction result is made, a node posts adds data to this database to show our result belongs to this request, right? That's basically what we're doing. We're building like an index essentially. We also have an API server, same simple premise. We import a API module. We import our entity. I'll show you. This is something that is done with type ORM. You need entities. So you set up your entity. This is basically your database model. So in our case, we have the request transaction ID and the result transaction ID. And then we also have a unique ID, because one request has multiple results usually, right? So we built this entity. we import that with this server, and here we're dealing with the entity. So we're making an API endpoint to a /Oracle/ID sort of endpoint. This will be an API endpoint. And what it does is it uses this request ID value to find the objects in the database, right? So in this case, we're looking up results. This is how a type ORM entity works. If you want to know more about that, you can look at the type ORM documentation. You do Oracle, which is our model, .find, very simple. The request ID, and then this data. And then if the results are found, it'll return the results. And that's what we are seeing in this front end application.
The request coming in.
Here.
Yes.
So you can see the request URL to an Oracle with this transaction ID. And what it does is it returns whatever data this relay node has in its database, it will return it to you. So invalid cookie value. Okay. I think I did some anti-spam thing in it. Or what this
if we go back to the API code, I mean, it's I'll just try to emphasize, you know, you had like 20 lines of code. Out of this, you had 5 lines of code to hook up a new API server and to register additional endpoints. And this is actually part of ARK core plugin that is now part of the whole network. So you're not limited by just using, let's say, public API network, but you can build your own network well, very easy with a few lines of code. And so imagine what you can do is just like additional microservice architecture, new client endpoints, Oracle integration. Actually, Dean, also you used a separate storage plugin, which is plugging in additional storage that is kind of not related to the blockchain.
It's unrelated to the blockchain, yeah.
But it still has the full ability to expand and store additional logic that powers your application. So
yeah. So this, I already built this plugin to be modular. So you can get this on GitHub. It is on the NOS on github.com/NOS. I think it's /storage-plugin. You'll find it. And I think the master repo is already like a framework, so you can just import that, require it into your plugin. You should fork it actually. You should fork it because you need to make modifications, and then you can just add your entities. So you make the entity. You just make a file. You structure it how you want your database to look, and then in storage.ts you import it. So you import it. You import it here as a module. Let's see where we're doing that.
Now we're in storage in
here we go. Import Oracle from entities. And then in the connection, you need to add it as an entity. And then you have your separate database. And then every time, what's really cool is every plugin where you import this entity, and you can do this in your transactions as well, where you import this entity and then you do things like you make a new model and you save it, it'll be in the database. So this actually is a nice intro to going back to the server. So we built our database, right? And our API. And if we go into our server plugin, which is the event listener for delegates, where they listen for new Oracle requests. So this might look a little bit complicated. I'm gonna go over it. Maybe we can go over it a little bit line for line. So we import our necessary modules. We define the logger, which is just logging for debugging, and the event emitter, which is for emitting events, which you can then use to later in other modules listen for events, right? And so the apps can communicate and the modules can communicate with each other.
And these modules are already part of the core, so you just import them and you just call the logic.
Then we import the secrets. So we check for the delegate, the secrets, which is your private key for your delegate, right? That's what this plugin is doing. It's importing your private key, and then it checks if it exists. It gets the secrets. It's an array, right? It's a JSON file. So, but when you're running a delegate, you only have one value in there. If you're running a testnet, there's like a lot in there, but yeah, so we get the value, we get the secret this way. Then we get the data for the wallet. We get the public key by calling this identities function. This is all part of our core, and we insert the secret here, and then this value is the public key. We import the wallet manager and wallet, which are two. So the wallet manager is a module that lets you manage a wallet. That's it. And then the wallet value here, this is getting the full wallet object for the
headers. Yeah.
For this delegate. So we use the wallet manager, we find by public key, and then we use the public key, which is received here from the delegate, right? So we have the wallet manager, and then we get the actual full wallet object for the delegate wallet. So now we can start listening. Once we have all this data, this is the essential data that we need for listening for incoming transactions and processing it as a delegate, right? We need to make sure we're a delegate first, and then we import that delegate data. So then we're going to start listening for the Oracle requested event. Now, if I go to the Oracle transactions, Oracle request handler, I didn't double click it, so now I have to go back later. And we go to emit events. You can see here it's emitting an event, and here it's imported like an object essentially, or an enum basically, right? But this is imported, and it's basically, it says here Oracle requested. I could have imported this as well, but I just entered the string like a TypeScript noob. So whenever a transaction is made, a Oracle request transaction is made that contains a URL, it fires this event, Oracle requested. That's it. That's all it does. And then when you build another plugin like this server, come back here. All it needs to do is listen for that specific event. So in this case, if on Oracle requested, it runs all this code that's within it, which is this. And it's not as hard as it looks. Basically, all of this is generating the transactions. Quite simple. So we're going to start with this part. So what we do is with the Oracle requested event comes the transaction data. So this already contains the request URL. So first what we do is we load in the database. We get the last block. This is no longer necessary, by the way. There's been a new PR pull request update, which I did in ARK core, which now it'll return an error because I didn't pull the latest code base. But now you can just, if you have the round calculator, which is also a core module, you can just do round info is round calculator, calculate round, and this will get you the latest round.
Log data, and everything is inside.
Yeah, and with that, you can just get all the active delegates. You can just do delegates, get active delegates, round info. Is that right? Did I say that right? Or is this the one that I updated?
I think you did a couple of PRs. I think both were there. Both were part of it.
Yeah, I think so too. Yeah, so I don't think you need to do it here either. So you just get the active delegates, and this is how you get the active delegates. You call database.active delegates. If that update isn't there, then it will be there after this presentation. So this is just getting an array, a list of all the active delegates on the network, and then we check if we are in that list. Right, if the node is running on a delegate, so a wallet is connected to it, which should be an active delegate. We check if we are in the active delegates list. So this is happening on the plugin side, on the delegate side. If I think, oh, I'm going to be a bad actor, it is running for myself anyway, so I'm going to remove this validation here, and then I'm just going to return this anyway. Then when the transaction is made, it'll fail when the other delegates have to verify the transaction when they forge the block, because what we're doing is this is making a transaction result, transaction, right? So we go to the handlers, and that's where throw if cannot be applied comes in. So once we post a transaction, it's going to check here again, is the delegate an active delegate? Yes or no. If not, it's going to return an error. So even though if this delegate, this node, starts doing some hacky stuff and wants to make changes to how they return data, If they're not an active delegate, it's never going to come on the blockchain because all the other nodes are going to verify this as well, right? So what we're doing here is we're importing the transaction data. So I'm doing it like this. I'm getting the interface, which is an interface that I built, which is just the URL. Yeah. So we can verify that later when we're programming, TypeScript knows, your Visual Studio or whatever you're using will know that this object here is only supposed to contain a URL. Then what we do is we make the HTTP request. So I'm using the GOT module, which is a very nice, simple HTTP request plugin. And I'm requesting the URL, and we are expecting a JSON object. So this is making it that it has the JSON headers. It gets the response code first, which should be 200, right? But we're not validating that, but we're posting it in a logger. And then after that, we can start building the transaction. First, we have the Oracle result object. This is what everything that the Oracle result transaction should have, which is the requesting ID, the requesting transaction ID, the response code, and the result.
So that is actually a transaction made by an active delegate who verified the URL and stored it as a transaction on the blockchain.
Yeah, exactly. Right. So we have all this data just by using a HTTP plugin. Right? We request a URL and we're putting it in an object. Very simple object building. This is very basic type the JavaScript stuff, right? You just make an API request and you put it in an object and format it how you want. And then comes the blockchain-y part. We're generating a transaction now. So we're getting a transaction builder, and you don't have to mind the version that's no longer necessary, actually. We're using a transaction builder to build this transaction. So how do we get to the point where we can build it, where we can have a transaction builder? That is a part of the crypto plugin. We go into our crypto plugin and builders. So this is what you will have when you have transaction builder. And I'm going to show you how what I used as a starting point for this, so you don't have to remember how this file structure works because you can just use things as reference. But yeah, so we're gonna build the result transaction right now. This is the builder, and this is basically telling whenever you call the builder to sign a transaction, this is all the data that that should be in it, right? That's being handled and being passed on to the transaction, the schemas, and all that stuff. We're building it here. I can go over this, but this is all well explained in the documentation. So I'm gonna leave this. Yeah, so I'm gonna leave this at this. It's quite simple. So this is how you have a builder. It's very simple. You just set your variables and your values, and then you can call the builder like this. And this is how you generate a transaction. And then you have a signed transaction. So basically what you're getting is a lot of numbers, right, and bytes, which convert to a transaction on the blockchain, which is signed by the private key of the delegate. So we know that it's the data can no longer be modified after it's been signed, right? Because then the signature will no longer correspond. So what we're doing now is we have the transaction. So now what we do is to our we know we have a local relay node on here on this delegate. So we can just call the local host with the API port. This is the relay node API port, and we post it to the transactions endpoint. Also using GOT. And in the body we have the transaction that's been generated here, right?
Yep.
And then it's posted. So here we're checking if it's been a success. If the transaction status goes 200 and it's been accepted, then it's a success. We no longer need to do anything here. And if it's not, we're going to log an error. But there's no error because this code is amazing. And then we also have a listener here because we want to listen for other delegates making these transactions as well, right? We want to make sure that other delegates that the database is being built up by all the Oracle results that are coming in to any node. So we're listening to the Oracle result posted event, which is sent by the Oracle result handler. So first we were looking at the Oracle request handler. This is the Oracle result handler, which is also emitting an event, which is Oracle result posted. So this event is fired the moment this transaction here that we're sending to the relay and is being picked up by the blockchain is accepted. Then this event will be fired. So when we post this transaction, this same plugin is gonna have this, get this event. And what we're doing here is we're getting the transaction data again, because this is a transaction.
Sure.
Then we're setting up, and this is where the custom database comes in. We're setting up a new Oracle object, and this is very simple stuff. And we're just building this this entity using type ORM. So the Oracle object is the entity, right, that we defined in type ORM, which had, if you remember, it has a request ID, which is the request transaction, and a result ID. So we're building that. We're getting the request field from the transaction. This Oracle result, as if you remember, it's this object which we sent in with the transaction, request, response code, and result. So we're getting the request, which is the transaction ID of the request, and then we're storing the actual transaction ID of the result transaction. So that's just these two details, and then we save it in the database, and then it is added to the database every time this event comes in, right? So that is the entire server plugin.
So you used actually your, sorry to jump in, the storing of the Oracle, you use it just to cache and to index the results of the transaction, so you can easily connect them with the, let's say, with the parent request, yeah? So you know which delegates responses can correlate to the actual request that came from the client. Yeah.
And as a quick note for storing data, so you're actually also able to store data directly in the state of the blockchain application that's running on your node. And basically what it is like a global array, a global variable, which is an array, and you can put data in there using simple setters and getters. I think it's app set, and then you just set
attributes or set, yeah.
Yeah, and then you have key, and then you have like value, right? Something like that. Set attribute, you said?
That's related to GTI. Not sure what.
Oh no, but there's a global one as well.
Yeah, that's just the app set. Yeah, you're correct. It's app set.
Oh yeah. Okay. No, it's not. Okay, it might be. Maybe I'm on a. Yeah. You need to look that up in the documentation. I don't know that by heart right now. But there's something that lets you just set something globally. The thing is, if you want to do that, you have to. Sorry, what?
The global settings related to the whole node, yeah, and what's running around it.
Right.
The app object, yeah.
Yeah, probably. So, but what we're doing is, because that's only for simple keys and values, essentially what we want to do is, I want to give you the opportunity to learn about, how more complicated things are set up as well, because a database, a real consistent database, can be used for more than just storing simple keys and values, right? You can do a lot more with it. You can handle timestamps and be like, I only want to find transactions which were made between then, and then you can do something specific with that. That's what a database really allows you to do. There's also, if you notice, I have this wrapped in a queue function. Queue comes with the storage plugin. What this does is it basically sends this entire task to a queue, so that the write task doesn't block the entire consensus process. It doesn't block any blockchain code. And also because if a block contains multiple Oracle results, it'll try to write this data virtually simultaneously, and SQLite doesn't allow that, so you have to queue it so that it's all done synchronously, right? So that's why this is wrapped in queue. You can just import that from the storage plugin. Right, so that's the entire premise of the server. And the storage.
Awesome.
So that's what we covered. I'm going to give a quick overview of what really goes into a transaction. So the request is actually quite simple, right? So the request model is built up. We're setting up our schema. We're giving it an ID, which is the unique ID for the transaction type. We're setting up what values are required. Now, normally, the required values in here should be the asset, which is where your custom data goes, and the type group. And the type group is actually the group that your transaction belongs to. So we have an Oracle system which has a request and a result transaction. These all belong to the same Oracle transaction group, which is just a number. But
yeah,
that's to make sure.
It's a way of grouping so that not different transaction types don't correlate. So actually you can have a transaction type 0, but it's grouped by a different type group. So you can think of it as a SLIP 44 standard, like a different naming for blockchain transaction groups. Like inside, if you'll be developing more plugins that will live on the ARK core platform, it would be wise to reserve, let's say, the type group number so it doesn't intervene with other blockchains, and you can then make it officially like a nOS type group, which is reserved and handles these transaction types.
Yeah. Yeah. So after that part, we set the amount, which is what we expect to be added as an amount. This is normally for transfer transactions, where you want to send something from A to B, coins specifically. This is not that type of transaction, so we don't want any coins to be attached to it other than the fees, which are handled by ARK. And then we build up our asset, which is assigning, we're saying our asset is a type. Usually your asset is an object, and then you put in the asset, you put the data that you require. So in our case, we have the asset is an object. The object requires the Oracle request. And the Oracle request is an object as well, which requires the URL. But if you want to simplify this, if you don't want to put anything else in the Oracle request, what you could have done is you could have made this the URL.
Directly
and then you just could have done this properties URL type. I think URL is a type schema. You could have just done this. This works as well. And the Oracle request schema. So this is like a nested schema, right? The URL has properties which are defined here, which is a separate file where I define it, but you can define it in the line as well. Yeah, we're saying the schema here is that is a URI. That's right. That's a URL structure.
URI.
Yeah. So
essentially the whole concept, the whole GTIs are extendable. The way you build your own transaction, other transaction types, they inherit the basic blockchain behavior from the ARK. So if you look at it at the line 15, it extends the basic transaction schema. It extends the basic transaction field. So as a developer who was building custom transaction types, as you said, all you had to do was define the parent schema and actually then specify which fields are part of your new transaction type, being URI and also, let's say, a type group which is related to the naming, so transaction type numbering doesn't overlap.
Yeah. So this is the simpler way.
Programming. Yeah.
This is a simpler way to build it, right? I did it in my way with the nested object because I wanted to leave the options open to add extra data to the object. But if you only expect a URL, you can just set the asset is an object. It requires the field URL, which has the properties that it has a URI structure, that's how you define it. We did it as an object, which is a little bit more complex, but same thing. Then we have the serializing and deserializing feature, which is for serializing the custom data and then deserializing it as well. I'm not going to go into this. If you want to know more about that, then you should check out the documentation. But essentially what we're doing here is we're converting it to a bunch of
bytes.
Yeah, we're converting it to bytes, and then we're converting it back from bytes into humanly readable or processable data.
Yeah, and actually the bytes are actually signed then with your private key.
Right, exactly. So the serialization is important for signing the transaction, and the deserialization is important for returning the actual transaction data.
What is also a very flexible part, I see that you used actually the default static fee, but with the 2.6, we actually extracted the fee logic. So by introducing your own custom transaction type, you can introduce your own custom logic on the transaction fee, meaning that you can actually make it static, like 1 ARK, 50 ARK, or whatever, or or define some kind of logic. I know like Gas has it on the Ethereum network or related to the transaction size, or you could actually define your own custom Oracle fee related to, let's say, number of calls or whatever. Actually, it's a separated method where you can just define the algorithm or the calculation that correlates and then returns the fee of the transaction.
Yeah.
Which is quite flexible now with 2.6.
Right. Okay, so let's see. So this is basically what the crypto plugin does, right? It has the builder, which contains all this basic data, and then it has the transaction schema, which is really the model and having some basic client-side validation in there as well. So if you send incorrect data, if you don't send a URL in this request, then it's going to be then it won't even build the transaction. Right, so you don't have to send any useless data to the blockchain. It's already being verified in the client side, because all of this, if you build an app, then your transaction won't sign if you don't have a URL in here. Yeah, so same thing for results. Also, it looks the same, but it has some different data in here. And then here as well, we have the result. Here we have the result transaction should be free, because they can only be made by delegates, and delegates can only post a result for each request. So delegates cannot spam the transaction pool, essentially, because when a request is made, it can make a free result request, but it can never make another free result request unless there's an open standing. Sorry, it cannot make another result. It cannot post another result on the blockchain. Without there being a relevant request, right? I can show you that in the handler in a minute, but we'll go over that. So it's a free transaction, no fees. It expects the request, the response code, and the result, which I think I set as, all strings. And then we have the functions to serialize and deserialize that as well. So it's essentially the same thing. You know, if once you get how this works, you just copy a transaction skeleton, and then you can just customize all this data, because once you know where everything is and you know how to define a fee, an amount, and an asset, it's very simple to just use a skeleton and start going from there. Yeah, so that's that part. So then for the handlers, so the blockchain part where we validate it on nodes and delegates before it really goes into the blockchain. So for the request, again, it's very simple. We leave everything on the default values, literally everything. We're not validating everything, because anything. We could validate extra. No, we don't even need to do that, because the crypto package is also used by the handlers. So the schema is actually verified before posting to the blockchain here as well. Is that correct, Kristjan?
Yeah, exactly.
Yeah. So so we can all leave this same, and then for the result, we have some checking here. So what I said is, you shouldn't be able, as a delegate, be able to spam these free results transactions, right? So before the transaction can enter the pool, the transaction pool, which is all the pending transactions which are going to go into the next block, before it goes into that pool, we need to check some things. So the first thing we're checking is we're going to make sure that only one result for the Oracle request can be made by the same delegate, right? That's what I just explained. So what we're doing here is, I'm sorry?
Yeah, exactly.
Yeah. So what we're doing here is we're going to look up all the transactions in the pool, in the transaction pool. We're going to filter it. We're using the filter function, which basically returns us each transaction. And then we're going to check. We're only going to work with transactions that have this transaction type, which is the Oracle result type, which is just getting the constructor of this, what we're working in, which is the Oracle. That there is a valid request and
active delegate, yeah.
Yeah. So So what we're doing here is we're looking up all the Oracle result transactions, which are made by us, by this delegate, by one delegate. So we're checking for duplicates. That's what we're doing here, essentially, right? We're checking for is there a transaction which is a result which has the same data as which matches the data of the transaction that we're checking now, and if the sender is the same as of that transaction as this delegate, right? So we're just checking if this delegate didn't just post 2 of the same results. That's what we're doing here. Sorry, I had to double check exactly what this.
It's a lot of code, so yeah, it's.
Yeah, so that's what we're doing. We're checking if the current transaction that's incoming, matches any transactions that are existing in the pool. That's what we're doing here. And if there is a transaction that matches, then this data will, it will contain more than one result. Actually, think it should be. Nope. Of course, it should be like this, right? There should actually be 0, if I'm correct. Yeah, there should be 0. So it should just be this, I think, because we don't want any other transaction to exist in the pool other than this one, and this one isn't in the pool yet.
Yeah, but okay. I think it was okay before, but okay. Yeah.
Oh yeah.
You're checking.
We should decide on that here.
Let's vote. Put another Oracle transaction.
I actually think it should be like this, because there should be 0 duplicates, right? So the result here should be 0.
Exactly, but one should enter.
Yeah, but it's not in the pool yet, right?
Exactly.
Yeah, so we're checking the pool for any transaction that matches the one that we're working with right now. So if it does, then we have the exact same result already coming in. So you can't make multiple. You can't post the same. Make a result transaction for the same request. That's what we're doing here.
You're actually protecting the pool from spamming. Yeah. Exactly.
Yeah. So if there's a request and I'm a bad actor as a delegate, I can be like, oh, I'm gonna send 100 results for this one request to dominate the data that's incoming. But this prevents that from happening. You can only have one. And then the other part is make sure there's only one result for the Oracle request by the same delegate. Make sure there's one result for this Oracle request by the same delegate. I think I have the same comments here. So let's see what we're doing here. We'll figure it out. We're getting transactions from the same type. Oh yeah, we're doing the same thing here. We're actually checking the
pending versus duplicates. Yeah.
Yeah, exactly. We're checking the pending. We're checking ones that are. Yeah, maybe you can explain this, Kristjan, because I actually forgot why why I duplicated this.
I mean, I'm not sure.
There we go. I know. We're checking them in the payload, which is the upcoming block, and we're checking them for those that are still in the pool. That's what we're doing. We're checking 2 different resources where transactions exist in the block. In the block.
You're checking the block also. Okay.
Yeah.
Yeah.
So we're checking everything that's upcoming in the block, and we're checking everything that's in the payload. That's what we're doing. So basically, we're checking these same things for the same thing, duplicates. And if there's duplicates for either, it's going to return an error and it won't work. All right.
All right.
And so then, so if this passes, it just returns true, and then it's going to enter the transaction pool. I think one is for the transactions that are in a. No, I'm not gonna continue to argue this because I'm actually not sure why I did this.
Yeah. We can agree later.
Perhaps it can be explained better in the ARK documentation. I remember copying this from my reference, which was the business registration transaction, which I'm gonna go into in a while, because I actually didn't know this data transaction either. Why this had
both were updated and also additional templates were made. So yeah.
Okay. So yeah, so that's the handler, the backend. That's all we're doing. We're checking for, and then we also have the throw cannot be applied. This is also a validation, right? This is for when you need to check things that are happening in the pool, basically checking for duplicates, all that kind of stuff. And then the other one is more generic validation, where you want to check more business logic type things. For example, if the delegate of this transaction exists as an active delegate, which we're doing here. We're looking at the active delegates. See, you don't have to provide round info in here. So we're checking the active delegates, and then we're looking up the delegate of this transaction, the sender of this transaction, and check if he is an active delegate, if they are an active delegate. then we're getting the results data that's already in this transaction, right? Because the delegate posted a result, and that's what we're checking here. We're looking up if the request exists in this result, the request ID, if it matches any request, and if it does not, then it returns an error, and if it does, then we can we run the super throw of cannot be applied, which checks for things like if the user has enough funds to pay for the transaction fees. So that's how we handle the transaction. That's the business logic part, right? That's all you need to know, essentially. So yeah, so we went over the storage module, which again, it's just building an entity, your model, import it in the server, import it in the storage, and then exposing that object, that entity in an API. That's the storage. Then we have the crypto, the front end, which is your models, which is building your schemas for basic client-side validation, but also for node validation. So you're building up your module here where you validate.
So creating transaction payloads, yeah,
and generating, signing the transaction. Then we have the blockchain logic, the actual business logic, where we check things in the transaction pool and things we need to do before actually making sure the transaction can be posted on the blockchain. This is where the consensus is reached, right? So this is your controller, essentially. And then we have the server, which is the application logic, where we actually do something with the transaction, right? We look for incoming events. We look for an incoming event. We listen to an event. If a request transaction comes into the blockchain, then we want to generate a result transaction and post that to the blockchain again, and then it goes through that process. So we use crypto here, then we post it to the API, and the API sends it, once posted to the API, it goes into the handler, the transaction handler, and then it's the transaction is made. Another event is done, the result is posted, and then it's stored to the custom database, and then any application can call that API endpoint that we're doing with our storage plugin, and get that data back as we are doing here. So what it does is, so we're looking for, what this does is, this is calling the, when you look at the response here on the right, what this does is it makes the API request, right? As we're posting it, let me check, as we're posting it, wrong one, wrong plugin.
The storage or the server, the storage, yeah.
Yeah, no, as we're posting it in, so we're revealing here, we're doing the, we're finding this and returning this data. That's what we're seeing here from the API. That's this. So I already made a test request. If I make another request, it's the same thing. I'm gonna make another request, and then you'll see that the ID will be 3 because there's 2 other storage objects in my database, right? So it goes through this entire process right now. It's checking every 6 seconds for a new block, and then eventually, once the result transaction is posted, it retrieves that data.
Should be 3.
See, ID is 3. Yeah. So this is the third data item because this is a new request, right? And I can show you what it looks like here as well. I have an SQLite browser. So on our node, I can actually open the database, which is right here. Browse data. See, we have 3 objects here, which is 3 rows, which is just the request ID and the result ID. So quick overview of how I connected this to a front end here, or for the application logic. I'm not going to go too deep into this because we're obviously, this is a blockchain guide, but with that belongs, you know, some app development, because eventually you want your blockchain stuff to go into a functioning app, preferably a cool one. So we're importing the Oracle's crypto plugin, the front end, with the builder, which was the basic part, and our interfaces, which is just definitions of, you know, what a certain object should have, or certain variables should consist of, right, for validation. So if you have an interface in TypeScript where it says this should be a number, then you can never assign a string to it, right? That's an interface. So here we are importing an interface because let's see. I'm not sure why actually. I don't think we're actually using that. So in this case, we actually don't need the interface. But yeah. So what we're doing here is I'm going to show you really easily. We have an
That's the
input
client
field.
side, yeah.
We have an input field with this is built in Svelte, by the way. I really love Svelte, and I really recommend using it for building your app because it's very simple. It's like vanilla JavaScript, but enhanced with real-time reloading of variables and just some really cool stuff. I definitely recommend looking into it. So this is some Svelte logic. We're gonna bind the value of the input, the URL, to our URL variable. And then we have a button where we run the create Oracle request function every time the button is clicked. So what we're looking at here is create Oracle request. We get the wallet data. Now this $sign is actually means it's getting data from a store, which is a very easy system in Svelte. So this is the wallet that we're logged in with. We're updating the nonce. The nonce is basically the number of transactions that exist on the wallet. That's to make sure that no duplicate transactions are made on the client side before posting. And then we're storing that new nonce with the wallet. So we're basically setting the wallet +1 because we're expecting to make a new transaction. We're setting our Oracle request, which is the I think this is where I needed the interface for, or where I wanted to use it for. This is the request asset object, right, for the request transaction, which was only a URL.
Which was part of the builder that creates the transaction. Yeah.
Yeah.
Exactly. The crypto.
Then we import the builder. We set up the builder. This is our builder, which contained the schema and the signing stuff, right? But it comes with a lot of other stuff as well. Like you can set your network. Obviously, you need to make sure that you're posting to the right node and that you're posting, for example, to a testnet and not a mainnet if you're testing things out. So this is the ID of our testnet, which I just said here. The nonce, which is the unique ID essentially for a transaction, which is just your last transaction, the number of transactions plus one. The asset, which is the request Oracle, the Oracle request asset with the URL, the object containing the URL, and then we sign it, and then we post it. So do transaction is a little helper function. We're just posting again, JSON object containing the transaction, and then checking the result. That's all it does. And then the transaction is posted. And then I also set something. I set the transaction ID here, so the app knows. Yeah, the app knows the new transaction ID. So this is a cool Svelte thing. If transaction ID is updated, this means to run whatever comes after this every time a variable on this line is updated. So if we create a request, the transaction ID is updated, it runs this if statement whenever transaction ID is updated, just by putting a $sign before. That's why I really like it. It's really cool and reactive, right?
That's cool.
Yeah. So what we're doing here is we are creating an interval, a loop to get the results, to get the Oracle results. That's just what this is. Every time a new one is requested, we clear out the previous interval, which we're doing with clear interval, and then we're creating a new one, right? And then we have get results, which is making an API call to our custom API, the Oracle's endpoint, with the transaction ID of the request, which was stored here, right, with create Oracle request. Then we look up the results. We fetch it and we resolve it. And then we just check with a for each statement. We check each result because it's going to return an array of results, which is just with the type ORM, right? So just the object with the different IDs, and which each contain a request ID and a result ID. It comes back as a list. And then if there are results, basically what I'm doing here is I think yeah, so what we're doing here is updating the object, right? So we're updating a global object. So if at later blocks more results come in, we're all handling that. But very simply put, we're checking all the results. And then since we're only getting the result transaction ID, we still need to resolve the actual transaction. right? So I'll show you what that looks like on.
You need to get the data from the specific transactions on
Yeah,
the asset.
because then you have the signature, right? If you
Mhm,
actually store the raw data, any node could update that raw data, and if there's like with this, you have like a result field which has the raw data, then there's no way to verify if it's correct. But if you have to go, if you do another API call for a transaction, so we have the request here, we have the result here. So now the app makes a request to the transactions endpoint, which reveals the blockchain transaction. I don't think I have this exposed in the, no, I should have it exposed here. Actually, I think I can see that here. Yeah, so this is a result transaction. So you can see
That's the
here,
whole payload,
oh, that's a delegate. Let me see, where is it? Oracle delegates.
Okay.
Oh, because it's already there, because we already did it in the start. So I'm gonna make a new one, and then we should see it show up in a minute, because it's only gonna check that transaction once. So give it a few seconds. There we go, it's revealed. So it should be somewhere here. Am I looking at this the wrong way? Do I have it not sorted correctly? Oh, filter, maybe. Oops. And my browser froze.
Yeah, you're giving me the hard work, you know. The oracles need to work.
Yeah. I actually think this should be revealed. Wait, give me one moment and I'll www.localhost.com. What?
Yeah, go there.
Let me maybe I can reveal it in here. There we go. So this is the transaction object. This is what's the full transaction. So you can actually check the signature. We can see the result here, right? This is our object containing the asset. So we have the request ID, we have the response code, and we have the result. That's what it retrieves after it has the result ID, and then it looks up the result value, and then it turns that back into a JSON object, right? And then it stringifies it again, basically. That's what it's doing here. So it's looking up the transaction with the transactions endpoint, and then it's getting that result. We get the object, specifically the result value, and then we push that to an array where we store it, and that's it. And then it's and then we have the Oracle results, and then here this is also svelte, so we just check for each Oracle result, all the Oracle results together, which are being pushed here, right? We're getting the Oracle result, which is every individual result, and then we're just putting that in a new paragraph. So that's how we reveal the results. So yeah, that's how we did. I think I've taken up enough time and complexity. Oh, one more thing, because that's important, because you don't want to learn, you don't want to know this by heart. You don't want to actually have to know about the crypto part and the handler part. You want a starting point. That's an important part. An easy starting point is ARK Core now at this time has magistrate transactions in their core packages. So if you go into packages and you look at core magistrate, you can actually get a nice reference here, which is the business registration transaction. And if you look here, it actually has a lot of logic in there and the entire structure you need. So this is the handler. You can actually use a lot of this stuff. So this is also, yeah, so you can use a lot of this stuff to build your initial transaction, right? You just need to replace the logic, but all the structure is here, and you can kind of use this as reference. And then you also have the crypto part where your schema is, your builders, your transactions. So I definitely recommend looking at the magistrate transactions, because all this stuff is already in here, and it gives you a good idea about how to build things. So I actually, when I built the Oracle transactions, I literally copied and pasted the business registration logic, and then just removed all the business logic from it, and then put my own inside of it.
Yeah, exactly. Maybe a comment, not just magistrate, basically all the stuff that is built within ARK, you know, we discussed a lot about now the custom transaction types is being used within core. So not just the magistrate, but also all other transaction types follow the same principle. So from transfer to delegate resignations to voting to hash time long contracts, each transaction has its own structure. And also they are quite well documented. I'm going to show you a bit later on what has been added to that. But definitely, as you said, in the looking at the code and the test is the best way to learn around. So.
Oh, sorry, 1 second. What the hell? Give me 1 second. Sorry.
Okay, no worries. Let me just switch to my screen.
Sorry.
Okay, no worries. Are you back?
Some audio just started auto playing from a video.
No
Which I
worries.
saw on Reddit of this this streamer who has Tourette's. She was saying some wild things. I hope the microphone didn't pick that up.
There was something, but yeah.
Okay. So yeah.
We'll cut it down.
Sorry, you were saying.
Yeah, I mean, thank you very much for your detailed presentations. I mean, you took us literally line by line, code by code.
Yeah,
so I hope developers here appreciate. And if you guys have any questions, I mean, feel free
and
to
fear
ask.
not, this is open source. So if you go into, I'm gonna make it a separate repo. Right now, if you go to my personal GitHub, github.com/deanpress, and then the core repo, you can actually check out the Oracle's branch. That's where this entire project is, and you can run it yourself and play around with it. Likely after this video, I'll make a separate repo. So if you go to github.com/deanpress and you look up the Oracle chain repo, you should see it. Should be fine.
Okay, cool. Dean, thank you very much again for all the details.
Absolutely.
I just want to add some content to GTI. You know, as we said, Dean already guided you to the documentation. We're actually rebuilding all the tutorials, all the guides. So if you head over to learn.ark.io, you're going to see it's actually targeted in 2.6 branch, which will be released when the time is right. But you have all the stuff here if you want to start developing, like how to set up your development, how to use on different platform from Linux to Windows, how to set up your first testnet. So basically what was Dean doing, he was running everything on his local computer, simulating the whole network. So if you look at how Ethereum does it, or other frameworks, it's quite easy here because all you have to do is spin up a local node, a server, and you deploy your applications. And essentially for the custom transaction types and the plugins, you don't have to copy paste, but actually we did, there's a repository, github.com/learnark, which will have more and more examples. But you can see here we have a template project, and you can basically just create a new repository out of existing one where all the basic logic is inside. So the transaction types, the naming, how you handle it, how handlers are implemented. So then you can just take it from there and look at how you have to implement a specific custom logic. And you have also a specific custom transaction example here, which covers in detail exactly what Dean was saying. And he was also working from this example, if I'm correct. And of course, but just to summarize, you know, it was really detailed presentation going through different scopes. But actually, if you look at different building blocks that ARK gives you, so Dean was using custom APIs, so you can register any new REST API and endpoints and custom servers on the chain, on the blockchain. He was using events. So he introduced our event emitter and just added additional events for oracles. Then, of course, the custom transaction. This is what I'm showing you now, the custom transaction module. And he was using our SDKs, which are more or less, let's say, 11 different languages that take care of all the crypto complexity. And also all the client API endpoints are already implemented. So all you have to do is just pick up your language of choice and take it from there. But for those, if it was too much or too more into detail, there's a really nice guide, basically covering two-part guide covering the starting building blocks. That's one part, and another part is then the custom transaction types. Is basically what all you need to know how to develop a module or a distributed application or application on top of any kind of a framework, and you'll see it's well, it's like normal software development. It's not something really crypto specific. You have to know maybe some of the mechanics, how the blockchain works, how the consensus works, but you can really start hacking and adding your new API points very easily. So yeah, it's nice to see so many people are still here. So guys, if you have any questions, Dean and I are available. So please shoot. Okay, looks like we gave them a lot of things to think about and to study. Dean, thank you again.
Yeah, absolutely.
I had a question real quick.
Oh, Mike. Hi, Mike.
Hey, hi, Chris.
Go ahead.
How you doing?
Very
Great
well.
presentation, Dean.
Thank you.
I was curious on the consensus of the oracles when you have a continuously varying data feed, how you would get them all to agree.
Oh, so there's no agreeing on data. So what this does is the oracles each return their own individual the individual data that they receive, right, from making a request, API request. So this this app here, so this returns one result, right? But that's because we're running one delegate, one node on one testnet. If you have a system with multiple nodes, the sample app I was showing you will actually have a list of various results. So what you have is not directly consensus. That would be up, in this case, it will be up to the app. So if you have, because maybe an app wants to request a price and then get the average from a number of results, right? Maybe they're not expecting for there to be full consensus and for the same result to be returned. So basically we're leaving it up to the app to decide on consensus. If the app wants to say the majority result is the result that we will use, then the app, the actual, you know, the one who made the request will be responsible for getting consensus on their data. So again, there's going to be 50 results, for example, 51 results, and then it's up to the requester to handle it.
Oh, okay, I see that now. And also, it looks like you're doing it on demand. So rather than keeping a running oracle that's continuously updated.
Yeah, so this is for requests, API requests. Yeah.
Like, yeah, so when a TX demands a request to result, then you use the API to request it from the Oracle API. Okay.
Yeah. So this is not a part of nOS, by the way. This is I made this specifically for teaching the basic principles of various things with building an ARK blockchain. So it's not, this sample is a sample. It's not intended for production, but I think it serves as a nice starting point to get an understanding and to, you know, move from there.
Yeah, it's really interesting. It's using demand instead of a continuous update. You're making less API requests.
You could actually, it wouldn't be hard to update it to do like a continuous data stream, right? It just depends on how, instead of setting up an API server, you can set up like a WebSocket server, right?
Great, thanks.
Okay, great questions. Do we have any other questions, guys? Okay. I had a list of questions, but I think we went through and we went through them pretty during the discussions. So maybe in one word, you know, the switch from I think before you switched to the ARK blockchain on the testnet, you were on Ethereum fork, and if you would have to describe the switch in one word, Dean, what would you use?
What would I use? ARK?
Yay. So it was the three questions. Yeah, awesome, great. You know, it's like how would you say the word? Guys, thank you very much. A special thanks to Dean for this detailed overview. A lot of this content is already available if you want to start building. A lot of it it will be shared in separate tutorials. I think Dean will be making one together also.
Yeah, I'll make a more so this is a live overview, and I'm going to make a more structured, clearer, not live tutorial, which kind of structures it. Yeah, it kind of structures everything into more shorter, shorter details, modules.
Okay.
It'll be a modular tutorial to keep with the the ARK mantra, modularity.
Modularity, reusability. Yeah, perfect. Okay, thanks, guys. Thank you everybody for showing up, and I guess we'll be seeing you in a month or so. So still in 2019. So thank you, guys, and see you in a month.
All right. Bye.
Thanks, guys. Cheers.
Bye-bye.